I would like to share with you some ideas and reflections on the issues of ethics in research concerning robotics. Robotics research has reached a given level of maturity today that enables to achieve an impressive level of capabilities in robots, for example, for navigation, for motion planning, for localization, for human-robot interaction. You see a lot of robots around doing many things, and really this is already impressive and is impressing the public. In addition, we have robots achieving autonomous operation, which means they are able by themselves to behave in a limited environment generally, but at the same time, it's really a system without any human intervention. And as a result, new applications are booming, and many industry sectors are interested in robotics, such as transportation, agriculture, construction, medicine, of course, manufacturing, and also defense. This spreading of robotics in society raises a few questions on ethical issues, on legal issues, and on societal issues. So, of course, when the general public sees robots around, and when the media sees robots around also, many questions are asked. For example, will the robot take our jobs? Will the robot take over the world, and AI also? Some application also specifically raise issues on the ethical basis for using robots, for example, in defense, in security. And as you may know, there are discussions at the United Nations, for example, about autonomous lethal weapons. That is, weapons which can decide by themselves for their targets and of course shoot autonomously on this target without any human intervention. There is a debate going on, and there are a lot of media papers and shows and so on that speak about this issue. So we are the researchers, we are the practitioners of robotics, and we have a role in this. We have a duty, which is first to educate the public on what is really going on in robotics, because the perception of the public is based on probably science fiction movies, on the media releases, on sometimes our own presentations, which are not always accurate on the limitation and the capacities of our robots. But not only to educate the public, we have also to reflect on the consequences of our own research. We have to have a responsible attitude in our research, because when our work goes out to applications and to practical use, it might be too late to put some safeguards, for example, or to consider some implications. Therefore, it's important as a community that we really look into those issues that are present in research upstream before it is sometimes too late to react on them. So, what are those ethical, legal, and societal issues? Here is a list. It's not, of course, a complete list. It's just focusing on some issues. For example, when you have autonomous robots taking decisions, what are the limits of this autonomy, and what are these decisions founded? Who is or what is accountable in this case if something happens which is not exactly what was planned for? Another question, what is the boundary between living beings and machines, for example? When we build robots that have the shape and the behavior of a living being, does this blur the frontiers between the living and the non-living? Those are examples of questions that we have to address, and I hope that during this talk I will give you some basic ideas or some orientation to be able to really consider the implication of our research in these areas. So robot ethics actually is not completely new issue, although it's a hype now. You hear many people speaking about this. Robotics researchers started reflecting on this more than 10 years ago, in the early 2000s, when, from their point of view, robotics became mature enough so that we can actually ground this reflection on ethics on real situations, real robots, real results. Actually several publications have been made, projects, workshops, and European Commission, for example, has funded several projects on robot ethics, which produced roadmaps and reports. And in some countries, commissions were formed. For example, in France, we have a commission that was formed in about 3 years ago, 2 years ago and a half, in 2012, to reflect on the issues of ethics of research in digital sciences and technologies. And of course, robotics is one of these sciences, and a group has come up with a series of recommendations concerning the ethics of research in robotics, and this is what I will try to convey to you in this talk. So the approach that we have adopted is to consider application domains, and from these domains try to extract what are the underlying ethical issues that are common or transversal to those domains. And the domains were selected to be not only posing ethical questions, but also representing what the robotics actually applications and commercial devices are able to do today. So those 5 case studies concern the applications of defense and security, rehabilitation, and human augmentation, assistance for vulnerable people like elderly and children, robot companions to the general public, and autonomous cars. I will go over each of them quite actually quickly, because from these we have extracted 4 robot capacities actually that raise ethical issues, and we made some recommendations on those issues. And those capacities are autonomy, human augmentation, emotions and bonding, and biomimetism, biomimicry. It's not really robot capacities, but actually issues in robot research that are raising those issues. So just to illustrate what I'm talking about, when of course you look to applications in defense and security, you have the question of drones. Drones are not autonomous robots. They are fully guided by human beings. Of course, they have some autonomous functions for waypoint flying from waypoint to another. But the decision to fire, for example, is a decision made by a human. Of course, there are considerations, as I mentioned earlier, that this becomes autonomous. So, and here comes the ethical issues in this area. Also, drones are used for surveillance, and again, they are not autonomous, but they convey a lot of information, and they can also be used in some autonomous mode if necessary. And you have also ground vehicles that are designed, for example, for counterterrorism, for explosive detection, but also for being used in the battlefield. These are application areas that immediately make the public sensitive to what might be ethical issues for them. Another application is rehabilitation. Rehabilitation, as you might think, is a very important application for robotics. It enables, for example, handicapped persons to achieve, to retrieve important functions that they have lost. For example, exoskeleton can help people to walk. For example, some artificial arms can be used to replace arms for people who have lost their arms, and this happens, of course, very frequently. For example, for veterans, for soldiers. In this case, it's rehabilitation. But sometimes this device that has been meant as a rehabilitation device might provide also an additional capacities, which is augmentation of the human normal capacity. And for example, you can use an exoskeleton by a person who is not handicapped for walking long distances, for having the ability to use the exoskeleton for heavy weights and so on. The third area is the assistance for elderly, vulnerable people, and so on. For example, in schools, for example, people with Alzheimer's disease, to have a kind of interaction that enables them to create bonds, for example. Also for telepresence with children who are in remote places, and so on. And about robot companions, this is not necessarily meant for people who are vulnerable, but it can be used also by people for just achieving assistance task. Bring me, for example, a cup of coffee, and so on. But there can also be used for other reasons that are not necessarily the ones that people have built them for. This is the fifth situation. This is the autonomous car. Of course, you have many car manufacturers and others who are interested in autonomous cars, who build autonomous cars. You have a few examples here, such as the Google car, for example. And the questions here are not necessarily about ethical issues per se, but about legal issues, responsibility, accountability if an accident happens, but also about so-called ethical dilemmas. For example, when you have an autonomous car and you have an emergency or accident situation where the car could hit someone if it continues on its initial trajectory, because this person just crossed the street suddenly. So the car can avoid this person, but by avoiding this person, for example, it can crash into a tree and maybe kill the driver, or at least the passenger, because the person is not driving. So what does it decide? Who does it decide to kill? These ethical dilemmas, of course, are just questions that even human beings don't solve or can't solve. So we shouldn't expect that machines are going to solve this in a satisfactory manner, but these are some questions. So let me now, from these issues, go to these examples, go to the issues that are raised by each of them, by the four areas that I mentioned and go to the recommendation. So first is robot autonomy. Robot autonomy, of course, has to be considered also in the context where robots and humans are present and share decisions. So it's actually, you have a situation where the robot is completely autonomous because it's some human using the robot, or the human is doing something, the robot is doing nothing, and it's just being guided by the robot, by the human, or there's a level of shared action, and it's so-called shared autonomy. Here, the questions that the researcher should reflect upon are related to the fact that maybe the human is not completely, for example, aware about the robot state, because robot is making its own computations, its own perception, and taking its own decisions. So we are not aware exactly of what's happening inside the machine, and suddenly the machine can take some initiatives that are quite surprising to the user. Also, another aspect, for example, is overconfidence. Humans tend to delegate some decisions to the robots because they think that they are more capable, that they have more knowledge about the situation. Also, for example, you have the issue of moral buffer, which arises if you are remote from a place where action is taking place, and therefore, if it's the robot who, if it's the robot that acted, actually, you might say, well, it's not really my responsibility, it's the machine. These situations are observed and they arise. So what should we give as recommendation to the researchers who are working on such systems so that ethical issues are considered? That's a first set of recommendation. Since we are building a system where human and robots are going to share authority, it has to be well defined by, when building the system, when defining the control system of the robot, what will happen during this authority sharing, and define clear boundaries, as clear as possible boundaries, so that there is no confusion and the information that is needed by the human to take its own decision is provided to the human clearly, and also with the limitations of the machine capacities. We have to take into consideration also that as when we do the research, that at the end, robot is a machine, and it's the human responsibility that is actually important. Therefore, the human, whatever the situation, should be always able to take over, because it's at the end the human who will be actually accountable, but also it's the human who has the most complete capacities in reflection and in the background, in the context, so that he or she can take the proper action. Therefore, when you design a robot that is meant to interact with a human, this is a clear recommendation, always enable the human take over. There are also another set of recommendations. For example, the fact that we can think that the robots or the machines are more capable because they know more. This is sometimes true, but most of the time we are not aware about the limitation of the robot, of the machine, because the sensors are not perfect, they are noisy, the computation is often based on probabilistic representations, for example. So it means that the robot decisions are not necessarily clear-cut. There might be some situations where the decision of the robot is based on false processing results. So it's important that we explain clearly to the user that there are limits to those machines, and that we enable actually the robot to express in its interaction with the user what are its limits, the capacity to qualify uncertainties, to explain robot decisions. Why did the robot decide to do this? So that there is no surprise. And there are, of course, methods to do this in research, but we have to take this into account as early as possible in our developments. Another point, the second point, is about human augmentation and rehabilitation. So the boundary is not always clear between rehabilitation and augmentation. And the question also is about what is the status of the augmented human with respect to the society, with respect to the person herself. The recommendations here are, first, that if we are doing rehabilitation, it means we are in a medical process, and we have, of course, to respect medical ethics. That's for sure. In terms of augmentation, maybe I can point out one issue, which is the notion of reversibility. If we are using a device to augment some capacity of the human, the use of this device should be reversible, which means we can remove it without putting this person, the user, in danger, for example. And the reason for this is that if it's removable, then the human can retrieve its, I would say, human normal capacities, and it will never become completely dependent on the augmentation device. It cannot be transformed permanently into some different being. And therefore, when working on human augmentation, this recommendation says that always enable the reversibility without putting in danger the person, which means we cannot actually, how do I say, clutch the device into the human and the removal becomes impossible in this case. I'm speaking again about augmentation, not about rehabilitation, and this boundary has to be clarified. The third point is about emotions. We have a lot of research in emotions going on, and but when you have a robot that expresses emotion or understands emotions, the reason that we do this, for which we do this, is that we think that it enables a better interaction, that humans will better accept the presence of the robot, and also the robot will better understand what humans are doing and therefore react accordingly. However, we all know as researchers in this area that a machine, a robot, doesn't feel anything, actually. It doesn't have real emotions as we human have. But this is not clear to the public. It's very important, therefore, to explain that robot emotions don't exist. It's just a word that we use to designate some capacity that resembles what happens in human beings, but has nothing to do with a real emotion that the machine has as we do. It doesn't have any meaning for them, for the machines. And when we explain this to the human, we enable to put a distance between what the human feel or perceive from the robot emotion, and to understand that this is not for real. And especially for young children, for example, who have difficulty to really know that a machine, because they didn't know anything before, is not feeling really emotions. This has to be very clear that the robot doesn't feel anything. I will, for the sake of time, I will go directly to the fourth issue, which is the biomimetism issue. Now, a lot of research is going on to build robots or androids, for example, in this case, from Osaka University, that resemble human beings or animals, for example, very closely, both in their behavior and in their appearance. I think that it's important here to stop for a minute and reflect on the purpose of this research and to try to understand why we want to build robots that actually look like human beings and what is the consequence. So when you see such a robot, you are going to believe, and this is meant, of course, to believe that it is actually very, very similar in everything, not only in its appearance, to a human being. And therefore, we are blurring the frontier between a human and a machine. And the question is that we, as researchers, have the responsibility to ask ourselves, why are we doing this? Why do we need to mimic living beings in the first place? Is it to understand how living beings work, for example? That would be a good reason. Or is it just to have this imitation and therefore we have to really discuss this issue, because from a society point of view, if one day you have actually operational robots that are able to move, to behave, to resemble human beings totally, then there will be a social question to address. It's not my role to answer it, but it should be addressed as a question. Okay, so to conclude, I think that it's our responsibility as researchers, as practitioners, to really ask the good questions about the ethical consequences of the research that we are doing, and consider some conclusions on how we orient our work in a responsible manner. Of course, this needs some international consensus, because it's an international endeavor to achieve research, and the difficulty is to have a good balance between open research. Everyone does what she wants to do, and between ethical recommendations, which might at the end put some limits on some research, like in biology, for example. It's important also to have operational ethical committees in the research labs, so that you can consult with them about such or such topic in your project. We have a document, it's currently in French, being translated into English, that you can download on the web. The address is here. That actually goes into more details, of course, than I have done in these few minutes. Thank you.